NASA has completed a comprehensive review of the launch schedule for EM-1, an unmanned mission of the SLS megarocket and Orion spacecraft ahead of future deep space travels. At the beginning of the year, the space agency assessed the feasibility of adding a crew to the mission but ultimately decided against it, and pushed the launch date back to 2019. Now, the follow-up assessment suggests scheduling issues could force further delay, up to June 2020, but for now, officials say they're targeting December 2019, as the majority of work is on track. The uncrewed EM-1 will test the Massive Space Launch System, SLS, and Orion capsule, laying the foundation for future missions with astronauts aboard. The plan has faced a number of setbacks, including challenges in building the core stage, which will be taller than a 20-story building, manufacturing and supplying Orion's first European service module, and damage from a tornado that tore through NASA's Michoud assembly facility this year. Still, the agency says much of the work remains on schedule. NASA has also set up new production performance milestones, after the review suggested there may be scheduling risks. While the review of the possible manufacturing and production schedule risks indicate a launch date of June 2020, the agency is managing to December 2019, said Acting NASA Administrator Robert Lightfoot. Since several of the key risks identified have not been actually realized, we are able to put into place mitigation strategies for those risks to protect the December 2019 date. NASA also says it will accelerate the test of Orion's launch abort system, likely for an April 2019 test date. Doing this will reduce risks for the crew that will eventually board the capsule in 2023. Earlier this week, NASA revealed a breathtaking glimpse at what it could look like when the SLS megarocket finally blasts off for its first mission. The space agency released a stunning animation this week simulating the takeoff of the Space Launch System, a rocket set to be the most powerful in the world. In the video, the massive rocket can be seen firing up its engines and plume of smoke, before lifting off the break through the clouds and climb toward the depths of space. The SLS rocket will launch with Exploration Mission 1, EM-1, of the Orion spacecraft. In recent months, NASA has made several steps toward the completion of the rocket, with key flight controller tests on the RS-25 engine conducted just last month. It will carry out its maiden launch in 2019 for an unmanned mission, then, in the 2030s, it could carry astronauts to Mars. With its unprecedented capabilities, SLS will launch astronauts in the agency's Orion spacecraft on missions to explore multiple, deep space destinations, including Mars, NASA explains. Traveling to deep space requires a large vehicle that can carry huge payloads, and future evolutions of SLS with the exploration upper stage and advanced boosters will increase the rocket's lift and capability and flexibility for multiple types of mission needs. The test at the Stennis Space Center in Mississippi in October lasted 500 seconds. Speaking ahead of the test, Philip Benefield, Systems and Requirements Team Lead for the SLS Liquid Engines Office, said, "The test that we're planning to run on Thursday is a 500-second duration test, which is typical of what we've done in the past. It's representative of a nominal SLS profile." During the test firing, the engine was throttled at thrust levels from 80% to 109% of rated power level, RPL. The engine was throttled at 109% RPL for 350 seconds, at 100% RPL for 8 seconds, and at 80% RPL for 78 seconds. NASA live-streamed the test, and footage revealed an enormous plume of smoke being billowed into the air. For the SLS vehicle, the engines will fire at 109% thrust level and provide a combined 2 million pounds of thrust. NASA is working to ensure the engines can perform at these higher levels under a variety of conditions. The agency is now working toward a 2019 launch date for the Exploration Mission 1, EM-1, mission. The test was part of a series of tests on the RS-25 engines this year, ahead of their use in the SLS. The space agency recently completed flight preparations for the 4 engines of the massive rocket. According to NASA, the engines are now ready to be integrated into the rocket's core stage, the largest ever built. NASA's priority is to deliver hardware for the first flight of the Space Launch System and the Orion spacecraft, said John Honeycutt, SLS Program Manager at NASA's Marshall Space Flight Center. This year, the SLS team has constructed major parts of the rocket, such as the in-space stage, which is already at NASA's Kennedy Space Center in Florida, the 4 RS-25 engines, core stage structures, and solid rocket booster segments. The 5 structures that make up the huge core stage are now complete, NASA says. This includes the section where the RS-25 engines will be installed. The SLS rocket will use upgraded RS-25 engines, which have proven their capabilities over 135 shuttle missions. Those to be used for EM-1 have supported a total of 21 missions so far, according to NASA. They'll be attached to the core stage ahead of green run testing, which will be the final test before the first mission. NASA has transformed these phenomenal engines that served so well in the recently completed the welding on the liquid hydrogen tank, marking the last of the 5 parts to be built for the rocket's core stage. The enormous core stage will be taller than a 20-story building, and carry more than 700,000 gallons of propellant. Prior to this, the engine was tested on May 23, when flight controllers for the engine were tested. According to the space agency, the flight controllers are crucial to the maiden flight of the SLS rocket, and are a key modification for the engines, which are former Space Shuttle main engines. The component is often cited as the RS-25 brain that allows communication between the engine and the rocket, according to NASA. Prior to flight, engine performance specifications, such as percentage of thrust needed, are programmed into the controller. The controller then communicates the specifications and ensures these are being met by monitoring and controlling such factors as propellant mixture ratio and thrust level. Earlier this year, NASA released breathtaking 360-degree footage of the moment a rocket engine explodes into life. The space agency fired up the engine, capable of delivering 500,000 pounds of thrust, that will power the SLS rocket, which will one day take humans to Mars. The first test on the engines of 2017 took place on the EM-1 test stand at Stennis Space Center near Bay St. Louis, Mississippi. Engine number 0528 ran for 380 seconds, 6 minutes and 20 seconds, allowing engineers to monitor its operating conditions. Staff at the Space Center captured overhead footage of the test using a drone, as well as 360-degree video footage.